Hi there. I want to go over some trigonometric integrals. Let's start with uh, integral sine raised to m x cosine raised to n x dx. Okay, I want to consider a case where either m or n, the exponent m or n, is odd. Okay, let's consider the case n is odd. If m is odd, exactly the same procedure would apply. So let me make up a problem with specific m and n values. So I want to consider this integral sine squared x cosine cubed x dx. Okay. The trick here is consider the trigonometric term that has odd power and split that into cosine squared x and cosine x. Okay, one of the terms should be cosine x and the remaining term would also be written here. Okay, sine squared x dx. So that's what I have here. Now next trick you need to remember is we have cosine x here. I would like everything else to be in terms of sine. So I can this is cosine squared x. I can write that in terms of sine squared, and that would make it sine squared x times 1 minus sine squared x times cosine x dx. If you are wondering how I wrote cosine squared x as 1 minus sine squared x, remember the identity sine squared x plus cosine squared x equals 1. Therefore cosine squared x equals 1 minus sine squared x. Even though this expression here looks pretty long, it's in the right form for us to do simple u substitution. Okay, so in this case I'm going to assume u to be sine x, and that gives you du equals cosine x dx. So make the substitution. I'm going to call this integral I, so I don't have to write that entire integral. So I then is equal to integral sine squared x, so that would be u squared, times 1 minus sine squared x would be 1 minus u squared, and cosine x dx would entirely be just du. And if I distribute, I get u squared minus u to the 4 du. And you can integrate this, and that would give you let me erase this. That would give you u cubed over 3 minus u to the 5 over 5, and of course there is going to be also a constant of integration. We need to substitute back for u, so that would be sine cubed x divided by 3 minus sine to the 5x divided by 5 plus c. So that's the final answer. I want you to try these problems. Integral sine cubed x cosine squared x dx sine cubed x cosine to 4x dx sine to the 4x cosine cubed x dx. Just small variations, the procedure is exactly going to be similar. Thanks for watching.